to my first video reviewing trigonometry for Year 11 mathematics. Now I intend to keep these nice and short and simple, so you'll see that we don't go too far in this video, but I will take it further through quite a significant number of videos, but short and sharp. So the learning goal for this video is to review the basic principles, language and notation associated with trigonometric ratios. So first of all, you need to know the language. You'll notice here that we use the word hypotenuse, opposite and adjacent to represent different sides in a triangle, and they will be important. You'll note also that there is this angle theta, and theta is always the angle in a triangle that is the reference point for anything we're discussing. You'll notice that the opposite side is opposite theta, and you'll notice that the adjacent side is next to theta, and adjacent of course is another way of saying next to. The hypotenuse means the longest side and is also found directly opposite the right angle. And if you take some time to think about that, that'll make a bit of sense why that is. So now let's talk about the trig ratios. And you should know the trig ratios. Let's start with sine theta is equal to opposite over hypotenuse. And cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. And this leads us of course to this common saying to remember them. So we have these clear starting letters leading to this saying: SOHCAHTOA, SOHCAHTOA. SOHCAHTOA is a good mnemonic way of remembering the order that the ratios go in and which trig ratio they represent. And of course, I shouldn't go without saying that sine is short for sine with an E, cos is short for cosine, and tan is short for tangent. So it's also going to be really important to understand what these trig ratios are actually doing and showing you. So let's talk quickly about sine. Sine of theta is opposite over hypotenuse. It's really important to understand that that is saying that the opposite side divided by the hypotenuse is always in the same ratio for a given angle. So let's say, for example, that the opposite side is always half of the hypotenuse. It doesn't matter what triangle you draw. Let's say this triangle here, which is 2 and 4, or perhaps this slightly bigger triangle and clearly out of scale, 100 to 200. It doesn't really matter what triangle you draw. If the ratio is 1/2, 100 divided by 200, or 2 divided by 4, then this theta will be the same as that theta. That's the definition. And then to take it a step further, our calculators have every angle classified. They have a way of telling you what that angle actually is to give you a ratio of 1/2. And I can tell you that sine of theta equals 1/2 gives us theta equals 30. And there are a couple other special angles as well. But generally speaking, they'll give us a nice acute angle between 0 and 90 degrees. All the best.